Okay, the session is being recorded. The tape is rolling, and this will be posted later on in the day to my TCC Blackboard for this particular classroom. And today we're going to be covering chapters 8 and 9, PowerPoint presentations on the material in chapters 8 and 9, on troubleshooting and connecting to a router and switch and actually putting some basic configuration into that device, like a password and things of that nature. This will be our last live lecture covering chapter materials. And then Wednesday will be our last live lab where you can meet in person or you can join me on the air, watching the tapes later, and we'll be doing 2 labs. The semester ends next week, at the end of next week. So normally you would, if this was normal times, you would be coming in next Wednesday, a week from Wednesday, and you take your final exam in the classroom. But during these times of mostly virtual stuff, what the upper administration has asked us to do is turn on the final exam for a week. So I'm going to turn it on at 9 a.m. this Wednesday, day after tomorrow, and it'll be on for a whole week through 9 a.m. the following Wednesday, March the 10th. You can take it. You don't take it one time, but you can take it any time during that. And like the other test, the Chapter 5, 1 through 5 midterm exam, it's open book, open internet. Now, there is a rule on the Cisco Network and Academy site. They have a business rule, or sometimes called a business requirement, that before you can take that final exam, you must take a thing called the course feedback form. It's an anonymous survey as to how you feel the course prepared you for a career, things of that nature. I can't see anybody's results at all. This is similar to, we also have another student satisfaction survey that's present on WebAdvisor, and I can't see who you did that, and I can't even see the results on that until after the grades are turned in. So you don't have to take the one on WebAdvisor if you don't want to, although the TCC is interested in your survey about how you feel about your classes. But this one you have to take. The course feedback form on the netacad.com site you must take before you can open up the final exam. So if you can't get to your final exam, go back and take that course feedback form. All work will be due by a week from this Wednesday, about 9 days from now, by 9 a.m. in the morning. So in this class, as a reminder, that's the labs. 50% of your grade is the labs. I do drop the lowest lab score so you can safely skip 1 lab. And then the other 50% of your grade comes from the 2 written exams, the chapter 1 through 5 sort of midterm style exam, and then this final exam. And those who want to come back for CCNA 2, I see some of you already signed up for that. That class will start after we have our spring break. So Monday, March the 22nd, 9 a.m. It'll be exactly on the same schedule we're being used to now. Every Monday at 9 a.m. there will be a virtual lecture recorded for later presentation and study. And every Wednesday I will be there in person in open lab. You can come in the open lab if you want to go and use the real equipment. Get your grubby grimies on the goodies and actually configure these real things. Otherwise, you can simply do it with Packet Tracer. Okay, let's see. I'm going to stop sharing this, and I need to start sharing the first PowerPoint file. Okay, this chapter is on configuring Cisco devices. Now we have used some Cisco devices in previous Packet Tracer and real labs, but we didn't ever configure them. For example, an Ethernet switch, just out of the box, 75% of Ethernet switches never get configured. They just go into small businesses, they plug them in, they start working. Routers have to be configured. They don't start working at all. They're all shut down. Everything's shut down by default until you start using them. But switches are not shut down by default. They start working. So any medium to large size business is going to want to configure these devices and put passwords on them, set up IP addresses and things of that nature, similar to what we would go through when we configured a home router to be used with your home cable or telephone company. So we're going to look at some Cisco LAN devices. Cisco's big business is in routers and switches. We're going to look at the features of the Cisco router. And in a networking device is a router. A router is a device that connects networks together. Your home router connects together your home network and your home Wi-Fi network with your cable internet service provider or your telephone company internet service provider. We're going to look at the Cisco IOS, which is a command line interpreter that we type in our commands, as opposed to when we configured that home router, we went into a a GUI, a graphical user interface, and we configured it by pointing and clicking with the mouse. The Cisco IOS is like the command prompt. We use the command prompt to do the ping. We use the command prompt to type ipconfig. We use the command prompt to type that nslookup command to check the DNS. So in the Cisco IOS, there's no GUI. The Cisco devices can't waste millions of lines of codes just to do pretty graphical stuff. So they just use a basic command line interface to configure everything. So we'll look at how that, a little bit basics, how that's set up, and some basic configuration commands. We'll get much more into this command structure when you come back for the second course after the spring break. We'll do some more advanced configuration stuff on the Cisco IOS, but we're at the CCT, the Cisco Certified Technician level, someone that can just unbox the device and rack and stack it and do a basic configuration and put a password on it so it can start to join the network. And then we'll configure a switch and router-based network. So let's look at Cisco LAN devices first. An Ethernet switch, we've been using the Cisco 2960 switches, both in our packet tracer setup and in the real lab we have Cisco 2960 switches. It's a device that has 24 fast, ours have 24 fast Ethernet ports and 2 gigabit Ethernet ports, but you can get them with 48 ports. You can get them in lots of different configurations. So one of the things we want to consider when we choose a switch to buy for our company is how many ports do we need? So the 24 port switches are very popular because many companies have 1 or 2 dozen employees. They just need a 24 port switch to connect their existing people and a few extra ports if they have any capacity growth in the future. We also want to consider what speed is required. Fast Ethernet is, it was okay 10 years ago, 15 years ago. I think pretty much the minimum speed you should consider, even in a small business today, for an Ethernet switch is a gigabit Ethernet ports. Get a switch that has at least 24 gigabit Ethernet ports. Some switches are expandable, where they can plug together and expand. Now, Cisco switches and all enterprise switches are manageable in that they have a console port or a management interface that we can use to configure them with. The little bitty $20 switches you go down to, well, you can't go to Fry's anymore, but if you go to Office Depot and buy a $15 Ethernet switch, well, sure, you can buy a gigabit Ethernet switch for less than $20, but it won't have any manageability. It won't have a console port. There's nowhere you can go in there and set up stuff and see what's going on. But Cisco switches, enterprise switches, they're manageable. They have the command line, they have the iOS interface, they have show commands. They could be managed in any size enterprise. Let's talk about what happens when a Windows PC turns on. So you guys that have taken an A+ class, you know, maybe you build a PC, you turn on a PC and you watch what happens. So normally when you turn on the PC, it does a power on self-test. It's checking for how much RAM memory is installed. It's checking to make sure there's no hardware errors. And when it finishes, and you may see some messages on the screen like it's counting memory. And then when it finishes booting up, it'll load the Windows operating system, typically off the only hard drive that's installed in the device. And then when the Windows operating system loads up, the Windows operating system will load something called the Windows registry, and then he'll know how you configured your copy of Windows to look the way you want to, what your password is, where your icons go, what your screenshot background is, and things of that nature. So when Cisco devices start up, they start up in a very similar fashion. When a Cisco device starts up, it does a power on self-test. It's a hardware test. So both computers, desktop Windows computers, and Cisco devices have a read-only memory, a ROM memory that has a special startup routine built into it. And they both do a power on self-test. And on Cisco devices, they have some LEDs that blink while these tests are being performed. When the tests are completely performed and the power on self-test routine is satisfied that no problem exists, it will stop blinking. Or it'll turn, if it's a problem, it'll turn orange or amber. Now this term out-of-band management, Cisco devices have a port on them called the console port. It looks like an Ethernet connection. It's an RJ45 female socket, but we don't plug Ethernet circuits into it. Instead, we plug a cable from our PC, going to the COM port on our PC or the USB port of our PC, with the proper type of adapter cable. And So devices like Cisco switches that don't have any type of management address yet, they'll work. They'll pass Ethernet along your network. Or devices like Cisco routers, they won't pass any traffic at all until they're configured. So we need to initially plug a console cable into the console port of these devices and set them up so that they can be part of our network. We're going to do the simple stuff in this chapter, like set the password, give it a host name. So when the Windows machine boots up, it loads the Windows operating system, which is pretty much the same for every Windows computer. And then it loads the stuff that customizes your Windows install for you, your password, your screen background, your icons, your colors, and things of that nature. So when Cisco devices boot up, they boot the iOS image file, which is an operating system like Windows, except it's not a GUI, it's a command line, it's a text-based language. And then it loads the startup configuration file. On Cisco devices, this startup configuration file is very similar to the Windows registry. It has your passwords. It has your configuration, your preferred personalization for that device. So it's going to run in your environment the way you want it to. So let's look at some interconnecting devices. Here is a Cisco router that's like the ones we actually have in the lab. It's a 1941 router, Cisco router. So routers are essentially, they're just like computers, like I was talking about before. They're essentially like Windows computers. They have an operating system. They have a CPU chip. They have RAM memory. And what happens to RAM memory when we turn off the power? It evaporates away. They have a read-only memory, which does the power on self-test, regardless of whether it's a computer or a router or a switch. And non-volatile random access memory, NVRAM, that's like the CMOS memory in your desktop computer that keeps the date and time. Non-volatile memory is called non-volatile because when the power is taken away, it doesn't lose its contents. So if you turn your computer off, it doesn't forget what day and time it is until the battery goes bad. And also in your computer, you can usually do a setup routine and say, I want you to boot from the CD-ROM drive first, and then I want you to boot from the hard disk drive. That configuration preference is stored in the NVRAM of the computer. The NVRAM in Cisco devices is used to store the startup configuration we wish to be loaded into the router or switch every time it starts up. We don't have to want to type it in each and every time just because it crashed and rebooted or the power was lost. So the Cisco routers contain a console port. Let me see, turn on my pencil here. So here's the console port that we would use in the lab. We plug the baby blue console cable into it. Actually, in the lab, we use an extension cable because they're not at your desk, they're back in the rack in the back of the room. Most newer Cisco routers contain a USB console port option. You can use one or the other, you can't use both. So you can plug a mini USB cable, which is like what you plug in an external USB hard drive with, to your desktop PC, and you might need to install a device driver. Cisco provides one. And then you would be able to use a console port, because many computers these days don't have the RS-232 COM1 ports anymore. The regular old style RJ45 requires a cable with the 9-pin RS-232 plug on one end. But even if you have a newer computer and you have a Cisco device that doesn't have the newer USB connection, you can buy for $10, you can buy a cable that has the adapter built into it. It has a USB plug to plug into your laptop or PC that lacks a real RS-232 COM1 port, and the other end plugs into the RJ45, so you can set up your device. Most Cisco devices come with 2 Ethernet ports. These are our 2 Ethernet ports here. There is an option to plug in option cards that have other capabilities. The ones we have in the lab have got 4 Ethernet connections in them. And they kind of look like a home router on steroids. You can also put serial ports in there to connect to the old style T1 lines and things of that nature. Hold on, someone has joined to collect attendance. Okay, we're good. So here is how we're going to set up a router. We're going to mount and ground the device chassis. We're going to screw it into a rack. If there is an external flash card in there, we're going to plug it in there. Now they normally come attached from the factory, but you can remove these little covers down here, right down here, and you can put in an extra flash card or change the flash card if you want to. Then we're going to connect the power cable to a source of electricity. Now, step 4. We are going to run a terminal emulation software on the PC and connect the PC to the console port with that baby blue cable if they're close together. In the lab, we use some extension cables to make that connection go back to the rack. And then when you turn on the router, you'll be able to see using that terminal program the messages. We're essentially going to take your $2,000 super high performance gaming Windows PC and turn it into a $70 dumb green screen terminal by running a terminal program on it. We use TerraTerm typically in the Networking Academy. Most versions of Windows PC also come with a program called HyperTerminal, which is the same sort of a thing. Back in the 90s, before we had high-speed internet access options, we typically would use like a Hayes dial-up modem. I call them the screeching cats modems because of the weird noise they make when you first dial up. And they were very slow speed, and they would attach to the serial port of a computer, and you would run a communication program to communicate with them. So HyperTerminal and TerraTerm are like these old programs. They allow you to see, instead of coming into the dial-up modem, using roughly the same speed cable, and you're connected to the console port of that Cisco router or switch so that you can start to configure the device. Now, he mentions at the bottom the 2 most common methods to access the command line interface are through the console port. We have to use that cable first, that blue cable first, to configure a Cisco device, like a router or a switch, to do any management on it, like put a password on it and put it in our network. The other method is once it's been configured, that's called out-of-band management when I plug into the console port. In-band management is once the device is configured and it can pass network packets back and forth with IP addresses, I can just telnet or secure shell to the proper IP address and log into that device and start using it. But you have to configure passwords before you can do that. If there's no passwords on the device, as a safety security measure, he won't allow you to connect to it. So let's look at the Cisco IOS. Now, hold on a second. I'm going to switch to the other machine, and I'm going to share. Let's see. I want to share an application, and I want that application to be Cisco Packet Tracer, and I'm going to share that. Let me see. I should have wiped this out for a second. Good. It's wiped it out. Good. So what he was talking about, plugging those things together. Let's just do a little kinesthetic exercise here and see this happening. So I'm going into a copy of Packet Tracer 8, the later version, because it has better Packet Tracer physical mode. It's got better physical features. And I'm going to click, by default, it's logical. I'm going to click physical. And I'm going to open the city. That'll open up the corporation, and that'll open up the wiring closet. And I'm going to put a rack in here, and I'm going to put a desk in here. And let me just do what he was doing earlier. I'm going to bring in a Cisco 1941 router, and I'm going to put him on the rack. So there he is on the rack. Let's see if I can do that's not a top of rack switch. That's a power receptacle. I'm going to move him down here, and then I'm going to get a desktop PC. Because he was talking about you have to plug something from your desktop PC. Yeah, let's go through. Let's do this. So let me see. Get a desktop PC, and I'll put him here. And let me see if I can blow this up bigger so it's a little easier to look at. Yeah, bigger, bigger, even bigger. Okay, that's pretty big. So here's a Cisco router, but nothing's plugged into it yet. So the first thing I need to do is, on this particular PC, I'm going to click on the jagged lightning bolt wires, and I'm going to choose the console cable. And I'm going to plug the console cable into the console port of the router, and then unplug the other end into the console port, the port of the PC. All right, now I'm going to open up that PC and go to the desktop, and let's go to the terminal program. So when you start up terminal programs, they will sometimes ask you what the speed is. And I'm connected to the, let me make this a little bit bigger. Can I make this a little bit bigger? There we go. Oh, you're not seeing that. Oh dear. All right, let me share the whole desktop instead. That should fix that. Hold on. Let me go back to stop sharing. And let me see if I can share Oh, you can see it now. You can see it now. Wait a minute. I want to go to here, and I want to go to here, and I want to share. I'm going to share my entire screen. That should fix that problem. So I'm going to share the entire screen. Click on the screen. Share the entire screen. Now we're going to get the echo effect. And let me go back to Packet Tracer. There we go. Now, there you go. Now you can see it. Okay, so the Cisco device is booted up. And he's asking us if we want to go into the initial configuration dialog. I'm just going to say no. And press the enter key. And we're ready to get started. So we're move this over here. Like this. So we're connected. Mouse, you can see my mouse? Good, you can see my mouse. So if you lay your cursor on the mouse cursor on the wire, it'll light up that wire so you can see what it is. So we're ready to configure that Cisco device. And we can start typing commands. Okay, good. So let me see. I can stop sharing this. And can I go back into here? Share files. Share this. Okay, we were talking about navigating the iOS. So once you make that connection using a communication program from your desktop PC, in the real lab, you have to use the Terraterm program on your real PC. Now in Packet Tracer, you can use some shortcuts. You can just click on the device and pop to the console screen without having to make that wire connection. But in the real world, you have to do that. So to learn some tactile response here, I put that wire in there so you can see it. So Cisco IOS is a command line interface, a CLI. It's text-based. There's no GUI to it. There's no graphics to it. There's no left click, right click, mouse to it whatsoever. We enter everything from the text prompt. So we've established a console connection. We attach the PC's communication port, COM1 port, to that Cisco router device. Or you might, if you have a laptop or a newer device that doesn't have a real communication port on it, a COM port on it, you can get some cables very cheaply for $10 or $15 that plug into the USB, old style USB-A, or even the new style USB-C ones, and connect to a Cisco device. So there's a security feature in the Cisco IOS that once you start using it, you're first at a thing, you're something called the user exec mode. My pencil still on? No, I've turned the pencil on again. Okay. So here, we're at the user exec mode here. And the reason we can tell is it shows the host name of the device. By default, the host name of the switch is the word switch. By default, the host name of a router is the word router. And that allows you to see what the host name is. We'll change it to S1, R1, something like that when we have multiple devices so we don't get mixed up. And then the greater than caret sign, that means we're at the user exec mode. It's like a read-only mode. We can look at stuff, but we can't make any changes. We can put a password even to get to that level if we want to. Then, in order to get to something called the privilege exec mode, this is the mode where if you know that password, and we're always going to use the password class. In the Cisco Networking Academy, you always use the first password is Cisco to get the user exec mode, and the second password is class to get to the privilege exec mode. You won't use that in the real world when you work. You'll use a hard password. But we do that so if someone forgets to erase their device when they're done, I can just put in Cisco in class and reset the device. So once I know that password is class and I type the command enable to get to the privilege exec mode, I can do all commands and features. I can see everything. I can even see passwords. So that's what we'll do most of our work on. We'll be at the privilege exec mode. So the command structure of the iOS is we're going to type a command. In this example, he's at the switch bomb. And notice he's at the user exec mode. He can't make any changes. He can do a show command. He types the command show. And then he types the argument IP. Show me something about the IP. In particular, what about the IP? I want to see the IP protocols that are running on this particular device. When he typed the command ping, he was at the prompt. He typed the command ping, and ping requires, well, what number do you want me to ping? And you put in that number, that IP address for him to ping. So say Cisco IOS has some built-in help that's pretty cool. You can type the question mark at any point when you forget what the next thing you're supposed to type is. Even if you're at the prompt, you don't even know what the first thing you type is. You can type the question mark. It'll show you everything that's available at that level that you can start typing. You're also allowed to abbreviate commands. So instead of typing out the entire SHOW, I might be able to type just SH and leave it that way, or I can press the tab key and complete it out. This is similar to some features that have been put back there in Windows now. These features are in Windows now, and then Linux and Unix, where you can type an abbreviation and not have to type the entire command out. Now let's look at some shell commands. The running configuration is a list of all the configuration that's running in this device at this moment in time. The active configuration is in the RAM memory. If you turn off the device without saving it, it's lost. So the running configuration is showing everything that's going on with this particular device. When the device boots up, it's kind of, if you've ever A+ stuffed around with like a Linux, and Linux boots up, a bunch of lines shoot up across the screen and they vanish off the top of the screen and you can't see them anymore. Well, if you know the secret command D, message D and message E, yeah, you can bring it back. So on Cisco devices, the stuff that vanishes off the top of the screen, like what's the version of the operating system, how many interfaces does it have, things of that nature, you can bring that back with a command called show version, and it'll summarize all that for you. And there are some other commands you can look into things. What are the interfaces that are present on this device? You can type that at the show command. Now let's configure a basic Cisco network. What we're going to do is do some basic configuration. We're going to configure the device name. In this case, we have 4 Ethernet switches, and we have 2 routers. We're going to concentrate on the router called R1, I think, at this moment in time. We're going to configure the device name, because by default it's router. We're going to change it to R1. We're going to secure the user exec mode, that is, we're going to put a password on it. We're going to secure the ability to telnet or secure shell into the device from another location over the network in band management with a password. We're going to secure the privilege exec mode, the so-called enable secret class command. We're going to take care that when you type this command show run, you won't be able to see the passwords in clear text. We're going to kind of slightly encrypt them so they're hard to see. Number 6, we're going to put a warning on there that your lawyers at your company will tell you what you have to say, and it'll say something like authorized users only, unauthorized users log off immediately, everything is logged. Then we're going to configure the management SVI, which is the switch virtual interface. It's a management address. Now the Cisco switch has no IP address on it. It's an Ethernet device. It operates at the data link layer. It doesn't need an IP address to operate. It will happily operate without it. And 3/4 of these that ship into business never get configured. They're just going into small businesses. But if you want to configure it and tell that into it from another location, for example, it needs to have an IP address. So we're going to configure an IP address on the device. And then finally, we're going to save this configuration so that it's saved in the NVRAM. On the router, we're going to do a basic similar sort of thing. We're going to configure the device name. We're going to compare passwords and save the configuration. Okay, so let's go. Let's get going here. To configure the interface, we're going to use a command. First of all, let's look at the interfaces that are present on the device. There's a very useful command called show IP interface brief that will list all the interfaces that are present on any particular device. In this particular router, we've got 2 gigabit Ethernet ports, and we have serial ports that typically intended to connect to at least telephone line, a data line to go to another location. So this can show us, in this case, we can see that 3 of these devices are in use. They have IP addresses configured, and they're up and up. They're operating. The other 2 devices, they're administratively shut down. By default on the routers, everything's administratively shut down until we actually start using it. Now let's look at some password configuration practices. The console is that baby blue connector that we plugged in from our, hang on just 1 second, I gotta scroll back to this. I gotta scroll back to who is here. Okay, I'll kind of attend this now. So at the console port, that baby blue connector, we want to put a password on this. So he's going to configure the command line console 0. He's in the configuration mode because it has the word config. He's going to type the command line console 0. I want to do something with that console port because by default, no passwords are required. Well, when you first start using the devices brand new, you start with no passwords. You get to decide what the password's going to be. So I want the password to be Cisco, and this is always the password we're going to use for the console port and also for our telnet ports, our VTY virtual terminal ports. Then I put the command login, which means take that password Cisco that I just told you and allow people to log in with that value. And then in the next portion, he says, there are 16 available internet connection management slots on this device, line VTY 0 through 15. I want you to also make them the password Cisco and allow people to come in through those network management interfaces and connect to the device. So that takes care of that. Now, let us also, because going over the network in clear text, someone could see everything, including my name and password with a sniffing program like Wireshark. I want to encrypt all that stuff. So this is the code to do this. We're going to make sure that the device supports secure shell. It has to support encryption for this to work. And we're going to type a series of commands that will turn on encryption and create a username admin with a password CCNA when they log in using secure shell. From a secure shell program like PuTTY, Terraterm will do it. So I can securely log in anywhere from on campus or off campus to a network device and be able to manage it and make sure that the Ukrainians or somebody are not snooping in and seeing my stuff. So to be able to see if it supports secure shell in the first place, we type the command show IP SSH. If it supports it, it'll say enabled. Now we have some older Cisco devices around that don't have encryption code in them. And if you type show IP SSH or show SSH on these devices, they will come back with a, I don't understand that command because they don't have the encryption code installed in them. You would have to upgrade that device with a newer version of code from Cisco with their support contract. Now PCs and non-router devices like switches need a default gateway to be able to communicate with devices on a different network. So your PC has got those 3 big lines. When you go into the network control panel, you're going to do the IP address and the subnet mask on the default gateway. The default gateway is what we call, our gateway is the old name for the router. So the default gateway is what I call your friendly neighborhood router. It's the router that connects you to the other places. So in this diagram, the PCs in this particular room, their default gateway is right here on this router. He gives them access to all the other networks that are present. Well, the switch needs the same type of information. So we need to configure the IP default gateway command on the switch so that he can communicate with his default gateway. So that's the purpose of this line here. We've configured it with an IP address so it can be managed on the network, but we also have to configure that switch. What's your connection to all the other networks? Well, my default gateway router, my friendly neighborhood router, so I can connect to those other materials. In this case, the lady administrator would not be able to connect with that switch if the switch didn't have a default gateway value to know to relay the answer back to her. Nothing complicated about that, right? Okay, so let's hang loose a second and let's go and look at the troubleshooting slides. So we're going to share some files. We're going to click on here. We're going to share this. Okay, testing and troubleshooting. Here we go. So what happens when it doesn't work? Well, we had the ice and everything stop working, but in normal conditions, what happens when it doesn't work? So we'll look at how to troubleshoot network issues. What are some common problems? And then sometimes it's in the industry, we have this concept called problem ownership. If it's within a device that's within my company and I'm the network administrator, I own the problem and I should try to fix it. If it's within somebody, if it's with Google or some other company or some problem with my internet service provider, I don't have the passwords to go tamper with their devices. They don't want me touching those. I don't own the problem. I have to call them and work with their customer support to do it. Okay, what if it doesn't work? So network troubleshooting is a process of identifying what's going on. What's the fault? What's the mode of failure here? Locating a specific cause of this problem and then correcting that problem. And here is the second one, maintaining good documentation. Oh gosh, a lot of network people are so overwhelmed that they don't have time to write down what happens. And then when the same problem recurs 6 months later and they've slept since then, they don't remember the solution and they got to do it all over again. So many companies employ what I call a problem solution database, so that in the business, 80% of problems that are encountered by technical support help desk people have already been encountered and already been solved. So that means that 4 out of 5 times he doesn't have to solve the problem. He needs to find the problem in the existing database and apply the known fix. So when you don't document, that stuff falls down and you actually create more work for your people. So we want to gather some information about the user that reported the problem. And maybe it's only affecting that one user, maybe it's affecting other users. And try to figure out what equipment that may be affected. If, for example, a user calls in and says, I can't log in, and I know I put the correct password in. Well, maybe he didn't put the correct password in because he had his caps lock key on, he didn't realize it. Because upper and lowercase are not the same in passwords. But maybe he actually is correct. Maybe he's a good user and the caps lock key is not on and he knows he put in the correct password and he can't log into the company network and do his work for that day. And so you might say, well, can you go slide over to your neighbor's workstation and see if you can log in on your neighbor's workstation? And he tries and he comes back on the phone and he says, yeah, I can log in from my neighbor's workstation. So we know his name and password are correct from a perfectly known good workstation. There must be something about that particular workstation that's creating a problem. So you ask him to have his neighbor come over to his workstation and try to log in. He can't log in either. There's some network connectivity issue with this particular workstation that the first user called in on. And then we want to try to isolate that problem down. So that's the troubleshooting process. We're going to go in stages and try to narrow it down. So some troubleshooting approaches are top-down, bottom-up, and divide and conquer. And let me explain. When we looked at that 4-layer TCP/IP model and that 7-layer OSI 7-layer reference model, the bottom layer was the physical connections, and the top layer was the application program, and in between we had, TCP and network layers and things of that. So a troubleshooting approach is, if you think it might be a networking issue, a protocol issue, from the top down, we'll find it more rapidly. If you think it's a wiring issue, like a corroded wire or plug plumb loose or something, bottom up would be a better way to start, because you're going to start with the physical layer first. And from my experience in the business, 75% of all problems are usually physical layer problems. A wire has been inadvertently pulled out or has gone corrupted or something of that nature. As you gain more troubleshooting experience, the divide and conquer method is a method that, well, I have an intuition for what's wrong here. I think he has a bad subnet mask. And you're going to jump right to the middle of the network layer and check the configuration on the device and see if that's the problem. Other approaches that are of value are the trial and error method. We're just going to just wild ass guess something here and try it and see if it fixes the problem. Now, if it doesn't fix the problem, we're going to immediately change it back to the way it was and totally reverse anything that we did, because we don't want to put a bunch of changes in there and then really host the thing. And we can try that till we fix the problem. That's okay for people that don't have a lot of troubleshooting experience yet. They're just going to eventually find out, and then eventually they'll get knowledge and experience and an intuition for what's wrong. Another method is the substitution method. So when I had the guy walk next door to his neighbor and see if he could log in at that workstation, that was the substitution method. I substituted another workstation and proved he could log in, proving that his name and password were good, and pretty much proving there's some problem with this workstation as well. So in networks, using your senses of look at the link lights, use your sight, look at those link lights. Are they green, blinking green? Uh-oh, it's blinking amber, or it's off, something's wrong here. I smell something hot, something is burning. Oh, look, there's smoke pouring out of that electronic device. And when they encapsulate the smoke in the device, that's what makes the electronics work. When the smoke gets out, it stops working. Touch something, oh, it feels hot. Oh, that's not proper, it shouldn't be that hot, it should feel cool. And you can hear noisy fans and hear screeching rotors and disk drives and things of that nature. So using software tools and utilities, we can run tests on the computer screen and try to figure out what's going on. So we used NSLookup to check our DSL, our DNS lookup process. We used traceroute and ping to check and see if we had network connectivity. ipconfig, we use that on a desktop PC to make sure the IP addresses are proper. Because if it's DHCP, which it almost always is, you can't see it in the network control panel. just has that button that says obtain the IP address automatically. You can't tell. You go to the DOS prompt, you type ipconfig, you verify your IP address, try to ping your default gateway, try to ping your server, things of that nature to do some more troubleshooting. So with Windows, we got ipconfig. ipconfig by itself shows you a very abbreviated display of basically just your IP address subnet mask default gateway. ipconfig/all shows you all this stuff. Yeah, what's my MAC address? What's my DNS server? What's my DHCP server? And if you're in a DHCP environment, which if you see this word DHCP server here, you are. Almost all the time we are. ipconfig/release will relinquish and let go of our network address that was given to us by the DHCP server. And then ipconfig renew will renegotiate a new connection. Sometimes that will fix a problem. Network connectivity, our friends are ping and traceroute. So ping is an end-to-end, tells us if the destination host is reachable. If it's not reachable, we're not going to get the replies. We're going to get the fails. If it works, well, that's good. The whole thing is the whole network path of 10 or 15 routers between me and that destination workstation are reachable. I can either type in the IP address if I know it, or I can type in the friendly English name and DNS will resolve that to the IP address. We did this in the previous lab. We did cisco.com and it resolved it to cisco.com's IP address. So if that doesn't work, we can use traceroute and try to determine where the problem has failed. So he says if pings to both the name and the IP address are successful, is probably some application program on the destination host. It's responding to ping, but maybe you're trying to get to the web server that's on the device and the web server is not working properly. If I can't ping, it's probably a network path problem somewhere along that destination. Maybe traceroute will tell me where the failure has occurred. If I can ping my own damn default gateway, it's probably not a local problem on my network. If I can't, oh, I have some problem with my individual workstation. Try some other workstation and see if that works. Now, warning Will Robinson, some pings fail because firewalls or routers are blocking the ping information because the bad guys use ping to map out the target networks they intend to next attack. So pings sometimes don't always work. Even when things are working properly, pings may not work. Yahoo.com usually works. You ping yahoo.com, it usually works. So we can use traceroute, which I call ping on steroids, if the ping fails. Traceroute essentially pings each and every router along the pathway and names them for you. And then when there's a disconnect between router 5 and router 6, for example, it'll show you what that is. It can't get from router 5 to router 6 or 7, 8, 9, 10, but it'll show you what the problems between 5 and 6. Now, if that's within my corporate network, I can try to fix it. If it's on the internet or some other corporation, I don't have any power to fix that except try to call them or wait for them to fix it. There's a program called NetStat that you can type at your DOS prompt that will show you all of the network connections that are taking place on your PC right now, what protocol they're using, what port number they're using, what connection the state is in, is it active, is it timing out, and so forth. We did a lab with DNS using NSLookup to use the NSLookup command to troubleshoot and test and verify the connectivity of our DNS server, which at home it'll be from your cable company or telephone company. At a company, it's usually that company, if it's big enough, Tarrant County College has got a couple of their own DNS servers. If it's a smaller company, it'll be the DNS service provided by their network connection, their service provider. Okay, let's look at some common problems. Divide and conquer method. Suggestions. Let's ping from a wireless client to the default gateway. Ping from a wired client to the default gateway. And ping from a wireless client to the wired client. And see what results we get. So we're working right at the network layer here by using ping as it's an application layer utility, but it uses the network layer ICMP echo request and echo reply to check and see if it has network layer connectivity. The bottom up methods, check the wires, check the LEDs. If the wire looks like it's plugged into that one of those 4 Ethernet jacks on the back of the home router, but the LED is not on, maybe the other end of the cable has come loose. Maybe that end is not plugged in properly. Maybe it's a bad cable. So we're looking at the physical layer to check for problems, and physical layer is oftentimes a problem. You must use the correct type of cable. Now, here's one thing I like about the current version of Packet Tracer. Packet Tracer will allow you to connect a bogus nonsense cable to a plug that it shouldn't be plugged into, just like students do in real life when we use the real lab. Yeah, if I plug that baby blue console cable into the Ethernet port, it'll snap right in. It won't work. So make sure you're using the correct type of cable. At the Cisco CCNA level, we have 3 types of cables. We have the console cable, plug into the console port. Then we have straight through Ethernet cables, and we have cross-connect Ethernet cables. There's 2 world standards for how these plugs are put onto the end of the wires, type A and type B. So you want to make sure that all the plugs in the jacks in the company match either A or B. Cables are only good for a maximum. Copper twisted pair cables are only good for about 328 feet. It's 100 meters. It's about 328 feet. It's about the distance between the goalposts of a football field from each end. So if you run over that length, you can go, a few feet over that length, it probably still work. But if you double it or something, it's not going to work properly. He says verify the correct ports are being used. Yeah, plug the Ethernet device into the Ethernet port on the LAN side. Don't plug into the WAN side. Don't plug into the console port. And protect the cables from being mangled or kinked or stripped or something like that that would affect their operation or prevent them from operating properly. Now, wireless problems. Not all wireless standards are compatible with each other. For example, the original 802.11a and the 802.11b that came out in 2000, they're completely incompatible with each other. 802.11b was the consumer standard. 802.11a was a scientific, medical, technical equipment. Completely different standards. Wireless conversations have to take place on separate channels. Now, there's like 14 channels in the United States, but they overlap each other. So if you're on channel 7 and your neighbor's on channel 8, you could interfere with each other. If you're on 1 and your neighbor's on 7 and the other neighbor's on 15, those are overlapping channels. Just like on a physical wire, the voltage and the currents, the power on the wire decreases as you go along the wire. That's one of the reasons for the 328 feet. It sort of, as we say in East Texas, it sort of peters out and we need to gussy it up again. So radio frequency signals also decrease with distance. They have a similar range, about 100 meters, 200 meters. Now, radio frequency signals are much more susceptible to outside interference from microwave ovens and baby monitors and things of that nature. And all of the available bandwidth is shared between all of the Wi-Fi devices that are attached to your home router. So it's like the old hubs, everything was shared. There are some newer wireless technologies that are more like switches and give you more bandwidth. Now, authentication and association errors. You must specify the correct SSID. So when you name your home router, it'll have a certain SSID. If you get it from the cable company or the telephone company's pre-configured, you're maybe stuck with that. Otherwise, you can make up a name. If you're using keys, the keys have to be the same. You configure the same key on your home router as you do on your Windows desktop PC or laptop PC. So the same encryption PC, it's got to be used. Now, all home routers come with a built-in DHCP server, and typically, unlike this print here, typically your home router will start sending out addresses to all the devices you plug into it, either the wired Ethernet plugs or the Wi-Fi, and it's probably going to be something like 192.168.1.100, 101, 102, 103 as you go in to connect devices. So click on your Windows laptop device that you're trying to connect via Wi-Fi, type IP config on it, see if you're getting a network address, see if you can ping your home router. That LAN interface address of your home router should be the default gateway, and it's typically 192.168.1.1. Okay, what if I can't get to the internet? So let's look at our router. So the router I've got from the telephone company, I can go to the router's management page and it'll show me, oh, I've got a good connection to the internet, or I don't. So let's check all our connections, all the LED lit up because the wires are plugged in correctly. Try to reestablish the connectivity. Now, if there's a firewall in there, there are host-based firewalls like Zone Alarm you can install on your desktop PC to try to protect you from incoming ransomware attempts and things of that nature. If your firewall is not, if you just put a new gaming application on there or something, but you didn't open up a port in the firewall, it's going to fail, just as if the wire wasn't plugged in. Some routers also have security connections on them. So check and make sure that those aren't causing the problem. Now, what if it's a problem that it's beyond your skill level, or maybe it's not it's not a problem that I own, problem ownership. It's another company. I need to call my ISP, for example. So I might need to connect the ISP, call to the ISP help desk, or my vendor help desk. So for example, Tarrant County College is a Cisco shop. We bought all Cisco routers and switches. For PCs, we're a Microsoft shop. All Microsoft servers and desktop PCs we use in Microsoft Windows. So if we run into a problem with Microsoft devices that we can't solve, we can call Microsoft. They'll help us because we buy lots of stuff from them every year. If we run into a problem with our Cisco routers and switches and our Cisco CCNP engineers can't solve it, they can call us a dedicated SmartNet Cisco support engineer, and he'll help them solve the problem. And he'll do it fast because we say it's affecting our 24-hour operations. So I talked before about documentation. If we have a problem solution database, it's called opening a ticket. Someone calls, let's say you work at the help desk, and someone calls in an incident to the help desk. I can't log into the PC. So this will be create a ticket, and someone will be assigned the ticket. And in this case of the slide, we have the computer will not start up. It's just sitting there beeping continuously. Computer is beeping. The customer, of course, doesn't know who manufactured the BIOS. Users don't know anything about BIOSes. He doesn't smell any smoke or burning electronics. So it's probably a misconfiguration error, or I'll tell you a story. My brother had me fix a Dell server PC. The power supply went bad on. So I replaced the power supply on it and got it to get up and boot operating properly. But when it started booting up, it made a beeping noise and came to an error on the screen that says, I don't know what date and time is. The battery doesn't have a charge on it anymore. So it needs to have the battery taken out of the motherboard, new battery put in. These are like little watch batteries that older PCs had to keep the date and the time in them. So I know it's not burning and catching on fire. It's putting a message on the screen that tells me what's going on. In this case, the computer doesn't boot up, so probably it's going to be a matter of the tech support person having to go and visit that person's desktop and try to identify exactly what's wrong with that PC. So sometimes people do weird things like they'll plug a Ethernet plug into the RJ45 network connection because it fits right in, but it shorts the computer out and won't boot up properly. So once the trouble ticket is resolved, we can put that in our problem solution database and update what the problem is. Don't plug that USB cable into the RJ45. Okay, that covers our two things here. So just to review again, I'm going to go back and stop sharing this. And then I'll go back and I'll share this. And it's going to be this. Okay, so we covered chapters 8 and 9. And what we're going to cover on Wednesday is these two labs, 8226 and 8543. And you get to a little bit of configuration on some Cisco devices, put in a password and things of that nature. So early Wednesday morning, I'll turn on the final exam. It'll be on for a whole week until a week from Wednesday. And you must take the course feedback form on the NetAcad site, the Cisco NetAcad site, before you're able to open up that final exam. All work is due by next Wednesday by 9 a.m. in the morning. And for all you guys that are signed up from next class after spring break, we will meet again on the same schedule. Monday will be virtual lectures, and Wednesday will be in-person labs starting on Monday, March 22nd. Okay, hang loose. I'm going to turn off my microphone and hang loose and stop the recording and see if anybody's got any questions for a minute. And then we'll call this another one for the